Hello everyone, we are a group from the National University of Colombia, and our research is about influence of the form of the perforation of the perforated block in the loose by acoustic transmission. Open wall walls are one of the most economical methods of solar control, which in turn allow free circulation of ventilation, and also use of natural light in addition to the recognized aesthetic qualities. The open wall blocks have generated great interest in the impact on the sustainability of passive design tools in architecture or in situ evaluation of thermal qualities. The exploration and development of walls built with open wall blocks do not indicate their behavior on acoustic transmission losses, since the direct incidence of noise on the wall involves the implementation of materials or geometries that can reflect sound and redirect sound waves. The absence of parameters for the acoustic design of the open wall blocks justify the exploration of the acoustic behavior of some commercial industrial open wall blocks offered in Colombia. It was used a deductive comparative analysis approach, and 6 different commercial open wall blocks were evaluated. The tools used was an scale reverberation chamber, a calibrated sound level meter arranged in the geometric center of the acoustic tunnel outlet 20 cm from the open wall block. It was also used a diffuse field speaker to reproduce 3 different signals at 500, 1000, and 2000 Hz. And finally, we used the Revit software from Autodesk for the 2-dimensional graphic analysis. It was made 2 types of evaluations: placed on one of its faces 90 grades and one of its edges 45 grades. It was also made an evaluation without the open wall block to determine the acoustic attenuation on behalf of the camera, considering that the sound level is attenuated as the sound propagates between the source and the receiver. This is the CO3 open wall block in 45 grades position or rhombic position, and this is the CO3 open wall block in 90 grades position or square position. In the results, the correlation between the mean of all the frequencies and each one of them indicate that for the frequencies of 500 and 1000 Hz, they are medium and low respectively, and behavior caused by the camera's model and will not be taken into consideration. The correlation for the frequency of 2000 Hz is high and positive, and that's why the subsequent analyses were only made with that frequency. We can see that the rhombic position of the open wall compared to the straight position has a lower soundproofing effect, as shown in the data in Table 2, which apparently has to do with the gradient length of the opening towards the sides, up and down. Also, the correlation between data according to the position do not conclude that the condition affects transmission losses. As a discussion, greater soundproofing efficiency was detected in open wall blocks with barriers in the internal composition. This allows to deviate the direct path of the sound wave. As an example, we can see the CO3, CO4, and CO6 open word blocks. Also, the rotation of the block has an influence in the loss by acoustic transmission. We can see that two open words have the same openings percentage, but they don't have the same behavior in acoustic transmission loss. We can see, for example, that the CO4 is 22% more efficient than CO1, both with 50% of aperture area. One of the conclusions is that the percentage of sound reduction found in the experimentation, in no case greater than 10% of the sound pressure of the source, are very low compared to those obtained by Ghaffari-Bardabak in 2019, close to 90%. But the results obtained are in blocks built with low technology, handmade, and not with a high technology. The geometry of the element, the size of the opening, and the complexity of the geometry in the perforation that increase the reflected field of incidence waves are essential for sounder insulation. It is necessary to evaluate the behavior of the geometry of the perforation at low frequency ranges. It has to do with the size and shape limitation of the reverberation chamber shown in the graphic. In addition, it is also necessary to evaluate material and mass. Thank you for watching.